Hey everyone, welcome to my channel. So this is going to be the first video covering some of the math concepts that I found interesting. So I recently just found a problem, and the problem goes as follows. Uh, so you have a hexagon, and then each of the vertices of the hexagon is labeled as the following: A, B, C, D, E, F. Now we know that A plus B plus C plus D plus E plus F. We know that this equals to 10. So then the problem is as follows. When you draw lines between each of these vertices, so you go like that, and then same as B, and you draw that for all of them, so on. Each of the midpoint of the line segment between two vertices is going to be the product of the two numbers. So for example, the line connecting B and D, this line is going to be B times D. So, and then what we do is, for each point on the line, we then replace this A with all the products of the 5 lines that connects it. So for example, for A, we have A times B plus A times C plus A times D plus A times E plus A times F. For B, we have A times B plus B times C plus B times D plus B times E plus B times F. So then we do that for all A, B, C, D, E, F, and then we take the sum of these. So the question is, what is the maximum value of this? Oh, whoops. What is going to be the maximum values of all of these sums? So we have to, for this problem, I'll give you some time to try first, and then after you tried, you can come back to this video to watch the solution. Okay, so now we'll assume that you've tried, and we'll start off the solution by introducing an inequality called Cauchy-Schwarz inequality. So Cauchy-Schwarz inequality. What this what this inequality says, it's that the sum of x, let's call it x1 squared, from I equals 1 to, I don't know, n, and then this multiplied by the summation of y I squared, so I from let's still say I equals 1 to n. This is greater or equal to the summation of x I times y I from I equals 1 to n squared. So, and equals, here, let me try to get rid of this. And equals only when x I divided by y, so x1 divided by y1 equals x2 divided by y2 equals x3 divided by y3, and so on. So, how are we going to solve this problem then? Well, we know that let's call an arbitrary vertice, let's say A. The sum of that vertice is going to be A times B plus C plus D plus E plus F, if we just factor it. Now, what does B plus C plus D plus E plus F equal to? Well, that equals to 10 minus 8, right? Because if you just isolate A from this equation, you'll get 10 minus 8. So A times 10 minus 8. This is equal to 10a minus a squared. When we take the sum of all of them, we'll see that they add up to 10a minus a squared plus 10b minus b squared, using the same logic, plus 10c minus c squared, and so on. So this equals to 10 times a plus b plus c plus d plus e plus f minus a squared plus b squared plus c squared plus d squared plus e squared plus f squared, right? So now we can use the Cauchy-Schwarz inequality because we want to maximize this. We want to minimize this. So if we want to minimize this, then this is always going to be greater than this part, right? So if we want to minimize this, then we have to use the equality symbol here. Okay, so let me just clear my screen a little. Okay, that should be good. And then, so then this part, a squared plus b squared plus c squared plus d squared plus e squared plus f squared, that is going to be greater or equal to, well, actually we need to define what y is. So this is this part. And then that, and then y, it's going to be 1 squared plus 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 1 squared. And the reason we want to do this is so you see this part right here, a, and then this part is 1. So then we can use a plus b plus c and so on the right. So that is greater or equal to a times 1. So a plus b plus all the way to f, and then that squared. Well, we know this is 10. So this part is 100 equals 100. And this, since this is 6, the minimum that this part could be is 100 divided by 6. So then this should be pretty easy to solve now. Plugging back to this equation, it's 10 times a plus b plus c, that equals 10, and then minus the minimum value for that, which is 100 divided by 6. So that's 100 minus 100 divided by 6. That gives you, okay, so this is 100 by 6, 100 minus 100 divided by 6. So that should give you 500 over 6. Huh. Yeah. So then, sorry, I was just checking this part. I was confused a little bit. So this equals to 250 over 3, and that's the answer. And if you want to know what each of A, B, C, D, E, F is going to be, you can simply do A divided by 1 equals B divided by 1 equals C divided by 1, and so on. So A equals B equals C. So each of these vertices is going to be A equals B equals C equals D equals E equals F equals 10 divided by 6. And you can plug this in to check that it works. But by using the Cauchy-Schwarz inequality, we've proven that this works. So yeah, this was a pretty neat problem that I've attempted to solve, and thanks for watching.